I'm Chas.
And I'm Ting Shen. We are from T3K2.
Today we're going to be talking about signal attenuation and the types of causes.
In this presentation, we will be covering what is attenuation and its measurement as well as the causes of its occurrence.
In addition, we will also look at the formulas and apply what we have learned on how to calculate the loss of the transmitted signal. So, what is signal attenuation?
Signal attenuation, sometimes also called loss, is a reduction in signal strength while transmitting any type of signal, analog or digital, over long distance. It can be measured in decibel, which is a signal unit used to measure the intensity of a sound or the power level of an electrical signal by comparing it with a given level of the logarithmic scale.
It can also be measured in watts, an international system of units as a standard unit of power, which is equivalent to 1 joule per second.
The graph below is an example of how signal can look like when there's attenuation. The waveform gets smaller and smaller, therefore signal strength is weaker, which results in signal attenuation, also known as signal loss.
So when does attenuation occur? Well, there are 4 types of causes that can cause signal attenuation to happen. The first one is long cable or long distance.
Both wire and wireless transmission gradually dissipate in strength over longer distances, meaning that the signal strength becomes weaker and weaker when the distance gets longer.
It is similar to when a person goes jogging. The further the distance, the more tired they get as more energy is lost. Secondly, wire size is also a factor for attenuation. On wired transmission networks, thinner wires suffer from higher attenuation than thicker sized wires. To understand it easier, think of the wire as an escalator.
When there's a bigger space, it can cater to one more people on the other side. But if the space in the escalator is smaller, only one person can stand on its stairs. Moving on to the third cause is the crosstalk. Crosstalk from adjacent cabling causes attenuation in copper or other conductive metal cabling. Crosstalk is an undesirable condition in which signal travel through adjacent pair of wires in twisted pair cabling, interferes with each other. The pair causing the interference is called the disturbing pair, while the pair experiencing the interference is the disturbed pair.
The last type of causes is defective connectors and conductors. Attenuation can occur as a signal passes across different conductive mediums and mated connector surfaces. Shown below are the formulas for calculating attenuation or loss. As mentioned before, signal attenuation is usually expressed in decibel. PI and PO stands for input and output power respectively. Take note that the value of the input power must always be equal or greater than the value of the output power.
The second formula can be used when you are provided with the voltage instead. Similarly, VI and VO stands for input and output voltage respectively. Lastly, you can also calculate the dBm using this formula. dBm is a specific unit of power in decibel when referenced to 1 milliwatt. For example, when I use the value 1 milliwatt, the answer will be 0 dBm. When it is at 10 milliwatt, it is at 10 dBm. We will now apply what we have learned in this example.
Given that the input power is 5000 milliwatt and the output power is 200 milliwatt, we choose this formula as it is the most suitable.
After that, you substitute PI with 5000 milliwatt and PO with 200 milliwatt and find the value of PI over PO, which is 25.
Put this back in the formula and you will get the answer 13.9794. When rounded off, it is 14 decibel. You can also substitute the values immediately in the formula, which will give you the same results.
We are done learning about signal attenuation. Thank you very much, and we hope that you have learned some basic understanding about signal attenuation.
These are the references.
Bye bye.